butterflies are flipping. Then let's move these particles along the mouse positions. First, put the in operator here because we want to pull in from the out this input connector here to acquire the outside signals from this component, and connect the mouse in operator signals as the default signals, and the mouse position signals is in the horizontal direction -1 to 1 approximately, and in the vertical not -1 to 1. It's about a half because the resolution aspect is long in horizontal direction. So let's check the output coordinates, normalize aspect to normalized. With this we can get -1 to 1 and -1 to 1 in vertical directions too. And as a specification of this component, we want to set as this -1 to 1 range into -0.5 to 0.5 range. So let's put the math operator here and multiply 0.5. And with that we can change the range -1 to 1 to -0.5, 0.5. And connect now here and apply this position to sphere's center positions Tx and Ty, and generated, and the metable's position too, center position to Tx, Ty, like this. But then when you connect another signals from the outside, for example the constant, make the constant and make the channels 1 and channels 2. With that signals, when you connect it to input, some error happens because this reference is written as the Tx and the Ty, but now the signal name becomes the channel 1, the channels 2, so it becomes the error. Then we have to change the name to Tx and Ty. So we have to add the name to this input signals of the containers to avoid these kind of errors. Okay, then disconnect this input of this channel. No need for this constant operators. Okay, now let's see the particle position with this render one, and as you can see, in the horizontal direction, the range is okay. They follow the mouse cursor, but in the vertical direction, it goes too far near the bottom and the top this kind of edge. So we have to adjust this kind of vertical range. In the earlier, we set the camera to orthographic and the auto width to 1. In that case, in orthographic camera view with auto width 1.0, for example, when you output the image with a resolution with 1280 pixels and height 720 pixels, this horizontal direction fits to the -0.5 to +0.5 position, so the image size becomes like this. The width 1.0 becomes the length from here to here. Under the situations, when you output the image with a resolution with 600 pixels and height 800 pixels, this fits to -0.5 to +0.5 position, so the image becomes like this. Okay, then we got a trick to acquire the resolution aspect adjustment. First, we use this parent parameters of the width and the height, and the parameters named W and H. For example, right click and copy parameters and double click the containers to get into that. Let's apply here the renders resolution, and this render one's resolution width is defined as here. So, and right click and paste references of that to parent ones, and copy it and paste to the height resolution too, and change the W to H. With that we can get a width and the height resolution of the parent containers. Let's apply the same operation to render 2 too, and then change and copy Control V, paste here and here too, and change the W to height. Okay, then with that we can apply the parent resolution to the two renders, and then let's change the height of these parent resolutions to full high vision size 28 and 720, and then with that Let's add the parameters operators here, and that shows the parameters of the operators written here. Two dots means the parent containers, that is here, and that let's check the built-in here. There appears the many parameters, that is the parameters of this parent, like these parameters written here. And then, but it's hard to see, it's too many, so let's select and delete asterisk and W and H. Then we can get the display of this parent. That is, now is the resolution of these two renders too. And let's select W and select and W, and let's make the proportion of these two values to the width to get adjustment. Then here is the math here. Put the math here and connect the parameters to the first and the second to the selected W's. And then there appears the selected W and the two W and the H values, and combine it with the combined chops divide. And then we can get the proportion of these two values to the width. Okay, let's multiply them to the most cursor position with the math, and you select connect here and select combine chops to the multiply, and then we can adjust the mouse cursor position. Range is now adjusted. Okay, then let's adjust the position of this operator to make easy to see the system like this. Then let's see the particle position with this render. Let's check the view, and now in the horizontal direction the range is okay, and the vertical now the range is okay too. And when you see the render too, these butterflies are also chasing this mouse cursor position. Okay, that's nice, I think. And that's all of the particle manipulation. So we want to make the output and this display. So let's make the background top for the displays with the switch top here, and connect first this render and the second to this particle position renders, and we can switch these two renders with this index value. Then let's rename the switch one to BZ, that means the background top, and let's get out and change the look to ./BZ this time. And next, make the output connector here and just put the out here. Okay, then we can get output here, and then for example connect to null here. We can get the butterfly particle render here. Then let's make the original parameters to acquire the inside the parameters. Another customize component windows, right click and select the parameters, and the parameters same as this text to particle containers parameters like this. It's the same as this. Okay, then let's get inside of this. First, make the texture parameters pages here, and then there appears the texture original pages. Then apply the texture 3D's parameters just here. Maybe it's this time cache size here, and set the reference expression to source. Okay, then another the reset button here. Okay, it's useful, I think. And then next, make the particle pages here, and then insert the particle parameters here. First, make radius, generator radius. Then this time it's a float. Then add the parameters, and that's too long, so let's name the parameters as red. Then let's apply it to generator radius. Here, particles here appeared. So get inside here, relative chop reference, then select 1. Change the default value to here, now the 0, then change the 1. Okay, then next, acquire these particle operators parameters here, reset buttons here. Set expression reference and source, and particles, mass attributes, and here we want to make sections to make it easy to see. Then the mass drag attribute, switch and drag parameters, and it's very useful of number of particles, birth rate, and set life expectation, life length of the particles, and the life of variance, and then alpha speed. That's all. Yeah, that's all I think. And then next make the force pages here of the particles. That's also very useful, I think. External force here, wind and turbulence, and the turbulence speed, periods, and the seed here, and other particle operators. This force parameter, the force here, that expression reference and source, and about the force, yeah, this position is nice, I think. And then this rectangle size become the butterfly size this time. So let's make the part texture size here. Okay, then that's all I think. Okay, sorry. Next, to make the view pages here, and that is the for the just display, and make index here. This, and it's better to change the index into toggle, not the float. Toggle here. I'll talk about the switching later. Okay, that's all. Explain some parameters we made here. First, let's make cache size become the frequency of this. So let's copy these parameters of this movie's frequency to here, the cache size. Paste the references. But the frequency itself alone doesn't work, so then we have to multiply me.time.rate, and that is the frame rate of this TouchDesigner. So that's written on here, and let's make a slash. With that, we can get the number of frame per one motion of this movie. Okay, then we can get the cache size. And other property is this size is the butterfly size. You can adjust the butterfly size as you like this, bigger or smaller. With this view pages and the index parameters, you can change the view like this. And you remember the red model is the particle generators, and the blue model is the metabole that is influenced to the forces, and the white particles appeared. We set the metabole huge enough to cover all these displays, so the all display become the blue. And in the particle pages, the generator radius changes the radius of this red model generators of particles. And you can change the forces that they worked on these particles or butterflies, something like this. Or with the birth parameters, you can change the number of butterflies like this. When there's a 20, so many butterflies appear, or you can set as 1 or 0, 2. With the parameters drag, you can apply the brakes on the speed of the butterflies popping out from the center point. And with the force pages, there's so many parameters too. For example, with the external forces, you can move the butterflies for a direction you want it. There's so many other parameters too. When you're interested in, please download the TouchDesigner's data from the link written on the explanation of this YouTube movies. Now we can see the butterfly particles with these view menus, and we want to apply a little effect on these butterflies with a blur trick. Insert here a blur operator first, and insert the over operator here, and put the original image over the processed image with the blur. Let's insert the level here too. And when you change the blur parameters, pre-shrink, or fit the size, there appears some effect around the butterflies that makes the butterflies look like shining, and there is some scattering brightness around the butterflies. Then you make the full scale. You can make the butterfly particles that traces mouse cursors. This mapping technique is very useful in many kinds of works that uses the particles or motion sensors. Okay, that's all this time. Thank you for watching. See you next time. Bye bye.